Okay, so this is part two of the video that deals with changes and physical and chemical properties. So let's see, where were we? We were about to talk about the chemical changes that matter can undergo. And in any chemical change, remember you're making or breaking chemical bonds. And usually you'll see chemical equations or chemical reactions written using the symbols, the formulas, separated by an arrow. And that arrow you can pretty much think of as yields to form. The reactants are the substances that are participating in the chemical reaction, and the products are the different and new substances formed as a result of a chemical change. Here's an example for you. A very familiar compound that you're aware of is carbon dioxide. If we're going to make carbon dioxide, let's just say we burn some charcoal in the presence of oxygen, we're going to get a chemical change, and you're going to yield to form a compound known as carbon dioxide. Now, we also know that in that chemical reaction, atoms go in and atoms come out. In other words, carbon atoms go in, oxygen atoms go in, and those same atoms come back out. So we can account for every atom of carbon and oxygen that entered into the reaction is coming out of the reaction. They're just now arranged differently. And that leads us, well, let's do some practice problems before we do anything else, just to make sure that we know what we're doing. So here we are, indicate if each of the following is a physical or chemical change. Take a second and then come on back and take a look at the answers. So here are your answers. We know that tearing a sheet of paper is physical because there's no breaking or making of chemical bonds. Burning a log is chemical. A way to determine if something is chemical, you've got some indicators that a chemical change is occurring. And I don't necessarily want to give those indicators away. You're going to be performing a lab in just a few moments where you're going to be able to tell me what those indicators are. Okay, so you've got melting a piece of wax is physical, melted butter solidifies in the refrigerator is physical, the rusting of iron is chemical, and the dissolving of sugar in water is physical. Just think to yourself if you're making or breaking chemical bonds, and that will give you the idea of whether or not it's a physical or chemical change. You will get better at that after you do the lab. Okay, so one thing I wanted to mention in that previous slide when we were talking about the formation of carbon dioxide, and that you can account for any atom that goes into the reaction has to come out of the reaction. So the quantity of matter remains unchanged. So the mass of the products in grams is always equal to the mass of the reactants, or the sum of the mass of the reactants. And that's another way of saying the law of conservation of matter, that matter can't be created or destroyed. Here's an example. If you have 48 kilograms of oxygen gas and 6 grams of hydrogen gas, and you react them completely to form water, how many kilograms of water do you think you're going to form? Right, it's as easy as that. The same amount of grams that goes in comes out. So if you add 48 and 6, you'll see that the answer is 54 kilograms of water. We can do that on an atom scale as well, and you'll learn that when we learn how to balance equations. Okay, so what I want to do with you now is set you up to do the chemical or physical change lab. You'll notice in the lab along the bench under the periodic table, you'll see some dropper bottles. And you'll see the paper that gives you the procedure for each station that you're doing. So you'll notice the first, I think the first combination that you're going to do on your paper is combining a starch solution with iodine. And I want you to take a look at the fact that you have dissolved a compound, starch, which there's a chemical formula for it, in water, hence making a solution. So the solute there would be the the starch, and the solvent would be the water that it is dissolved in. Now iodine I can represent using a chemical symbol, I, with 2 atoms, so that element exists as a molecule of iodine. And what kind of matter is that if you had to classify it? Right, it's an element. It's found on the periodic table. It only contains one type of atom. So here we are. We are going to combine these substances together and we're going to see what type of change happens. You're then and you'll notice there's a watch glass there. It almost looks like a glass dish. What I want you to do is use that instead of what's called a depression slide. You only need a very small amount of each solution. I think with iodine you actually only need a drop. So please make sure that you're following the procedure, and less is more. Like, okay? So don't, overflow the watch glass there. Okay, you need to have goggles on for this, for all three of these combinations as well. You'll notice the next thing you're going to do is move on to the silver nitrate combination with a salt solution. And again, the bottles are labeled. Your goggles need to be on. And again, just a couple drops of each on the watch glass, and you'll see what happens when you combine these pure substances together. So silver nitrate solution, you guessed it, is a mixture, and when you look at it, think of it as, is it a homogeneous mixture? Is it a heterogeneous mixture? So have these concepts in the back of your mind when you're dealing with these substances. Okay, you're then going to combine a strong acid known as hydrochloric acid. Again, goggles on, they're in a dropper bottle, so it's absolutely safe, but I still need you to be very careful when you're dealing with that acid, because acid on your skin does not feel good. Okay, you're going to combine that with solid zinc. You'll notice the solid zinc particles are in the Dixie cup and they're labeled zinc. You're going to do that combination again on the watch glass. So same watch glass, but each time after you're done combining the materials for each one, you're going to take that over and you are going to rinse off the wash glass. You'll notice there's a beaker in the middle of the lab bench there that says waste beaker on it. What I would like for you to do is use the wash bottle and just rinse off your watch glass in between reactions. The materials that I have here should not be going down the sink. You'll notice the waste beakers there, and I just need you to rinse off with the water bottles so that each of these materials is disposed of properly. Okay, so the whole purpose of this lab is to determine if the substances, when they are combined, undergo a chemical or physical change. And on your lab sheet, you'll notice that you're going to indicate to me how you knew that. Okay, so there you are. Ask me if you have any questions, and I hope that was helpful. Make sure that you hand in your paper at the end of class. Okay, sorry. One more thing. If you, as you're doing this, I don't want everyone to be over on the side by the lab bench. So as we all are doing this lab, you can take individual little bottles over to, as you know, your table, over to your actual student bench there. So we're not all at the windows. Okay, so just take, depending on which one you're doing, take those little bottles over. When you're carrying the watch glass back to the waste beaker, just be careful when you carry it, okay? And you shouldn't have that much material on it anyway, because remember, we're going for the fact that less is more. A couple drops of each thing and you'll be fine. Okay, thanks so much.